Everyone to this session, ArcGIS API for JavaScript 2D visualization. My name is Christian Ekenis. I will be presenting alongside my colleague Jeremy Bartley. And in this talk, we're going to be discussing and demonstrating various ways to visualize your data in 2D map views. So what I'm going to do is I would like to blow through the slide deck as quickly as possible to introduce the topics, and then we will spend the bulk of our time showing off demos and demonstrating how to achieve certain 2D visualizations. The goal of this session is to not only show you how to visualize data with the ArcGIS API for JavaScript, but how to do it meaningfully. And one of the overarching themes that we're going to cover is that one visualization cannot tell a whole story. So you'll notice that some of the data sets, or we'll use some data sets that span multiple apps because we want to explore it in different ways with different dimensions. So how do we create visualizations with the JavaScript API? That comes down to two sets of classes, renderers and symbols. Before we dive into the particulars of each of those, we're going to talk about the different things you can visualize. Of course, we can visualize where things are. We're a mapping company, so you want to be able to put a point on the map and see where it is. This is hurricane locations. You want to see what it is, a category, a type, a point of interest. How much? Where did people vote? How many people voted for a particular candidate? When? Was my incident closed on time, or is it still open and did it pass the due date, or was it closed early? Or you can do combinations of those styles or questions with a multivariate visualization, such as this one, which shows ocean temperature, velocity, and direction in the ocean waters. Okay, so I already said that symbols are classes in the API that we can use for visualization. So what exactly can we do, or what kinds of symbols can we build? In reality, you can build basically any symbol you want to, but we have some primitives that are available on a fundamental level. We have basic lines, fill symbols for polygons, and marker symbols for points. We call them simple symbols, like simple line symbol, simple fill symbol, and simple marker symbol. And these are the code snippets that you can see how to easily build them. Because of autocasting in our API, you can simply build simple objects with the properties and set them in your renderers. You can do a little more than that. Let's say you have a slightly more complex symbol or you want to achieve a particular visualization. You can use a picture symbol to do that. There's two types. There's a picture marker symbol, and that's simply, I want to use a picture to represent a point. So in that image off to the top left, you see census tracts in the Los Angeles area, and we're using what are called firefly symbols. It's basically these glowing picture symbols to represent the location of a census tract, and the color and brightness of that picture represents the amount of income the people make in that tract on average. You could also do animated GIFs to represent a location, such as this hurricane. We also have picture fill symbols. So if you want to represent areas such as marsh or wetlands or even glaciers, you can create an image that represents a pattern that repeats as you see in these examples here. We also have a more complicated and complex symbol called the SIM symbol, but it's an extremely powerful one. SIM stands for Cartographic Information Model, and what it does is it allows you to build high quality scalable symbols. So if you look at this Ferris wheel symbol for amusement parks, you can see that if you have a picture marker and you scale it, it can get blurry and fuzzy and not look very good. But a scaled vector, such as an SVG, allows you to scale that image and it works across multiple scales. These are composed of multiple symbol layers. So if we're building a globe or light bulb type symbol like you see in that purple rectangle, it's composed of 3 different symbol layers that are basically stacked on top of one another. What's cool about the SIM symbols is you can drive or override, I should say, any of the symbol layer properties based on data values, and that's called primitive overrides. Now we have a separate session that's all about SIM symbols in the JavaScript API. And if you want to learn more about how to create data-driven visualizations with them, I highly encourage you to check that session out. And this is how you use the a sim symbol in the ArcGIS API for JavaScript. You have to, it's basically a giant object that you have to reference in the sim symbol class. Again, if you want to learn how to use them, I encourage you to check out that session. We will show one or two examples of them in this session as well, though. And finally, we have something that is called the web style symbol. Um, on the most fundamental level, this is basically a sim symbol instance, but we wrap it in some helpful or some easy to use language so you can reference common symbols. So in this example, I'm visualizing the number of visits to each national park and whether it changed over time. And because I want to use this common tree symbol and that's published with our API, you can actually reference just that that sim data with just a couple lines of code. And it's identified by this park name. And if you set a style name, this points to these styles that we provide out of the box in the API, and you can just paste it into your app and it will work. You can also publish your own web style symbols for use. If you have a common symbol that's custom built by your organization, you can definitely bring that into your apps. Again, this is covered in that sim session I mentioned before, so I highly encourage you to check that out if this is something that interests you. We have dozens, or I believe even hundreds of web styles that are available out of the box in our API. So if you look in our documentation, this is our homepage, and you expand this data visualization folder, you'll see both 2D and 3D web style symbol resources. You can scroll through them, find one that appeals to you, and then you simply just click on the card and you can copy and paste that code into your app. Now that we have a fundamental understanding of what symbols are in the API and how you can create them, now we need to talk about renderers. I like to think of a renderer as the method that you as a developer can ask questions of your data. It allows you to define ways to override symbol properties, such as the size of a symbol or its color, based off of data values. We have a number of renderers that just come out of the box in the API, and these are what you see here. The simple renderer, that's basically answers the question, where is my thing located? So if you want to see cities or highways, just give them all the same symbol, and I can visualize it that way with a simple renderer. There's the class breaks renderer, which allows you to define data ranges as discrete class breaks, or the unique value renderer, which shows categorical data. So what type of highway exists here, or what is the point of interest? Is it a church, a park, a school? The heat map render, it shows how densely packed a set of points is within a layer along a continuous surface. So this is an example of earthquakes at the Kilauea volcano in Hawaii. And there's also the dot density render. This is a cool visualization technique that shows the density of a count or population, and you can even color the dots based on a type. We'll show that example a little later. And another part of the render is something called the visual variables. A visual variable is, I like to consider it a property of a symbol. So you have a color for a symbol. You could have a symbol size if it's an icon or a line. You could have opacity on that symbol or even rotation. And each of those things you can change based off of data values. So it's all about numbers. You can't use strings here. But if you look at these examples, and I'll show more live in a second, these show how the symbols of different features and different layers are changed by data values, like this weather data down here. The rotation, the color, the size of those symbols are all driven by data values, such as wind speed, wind direction, temperature, or maybe it's population with icon size, or the color might indicate the percentage of people in poverty. So there's a lot of possibilities with using visual variables. You can just apply one visual variable to a render, you can apply multiples, or you can basically do whatever you want. So this is what the code looks like when you want to create a visualization or a data-driven visualization. You create a simple renderer, and there are various components of that renderer. In this particular case, we're visualizing the number of active or COVID cases since a particular date. So what you do is you set the symbol on your renderer. So I want to symbolize all my counties as a marker and give it a color or give the outline a pink color that's pretty thin, and I don't want to fill it with anything because there's a lot of overlapping uh, markers. Then you can override one of those variables or one of those symbol properties using the visual variables. So in this case, I want to change the size based on the total number. So if I have a field in my data called infections, I can reference that in my size variable, and then I can set up a series of stops to indicate how large I want to make an icon based off of real data values. So if I have an area like New York City where there's over 200 cases, or sorry, 200,000 cases, I'll give it a very large icon of 200 pixels, and it will scale downward based off the number of cases. Well, you can also do more complicated, or I shouldn't say complicated, but you can do more with your data using arcade expressions. So in this case, we want to visualize the rate or the number of infections per 100,000 people. So instead of using a marker symbol, I'll use a fill symbol. And in this case, the color doesn't really matter because I want to override that with a color variable. And in this case, I don't have a data value that indicates the rate. So I can use something called an arcade expression. This allows me to write a client-side expression to calculate a new value. So when I don't have a data value, I can take existing values in my data and calculate something new. So I know the number of infections, I know my population, I'll calculate the number of infections per 100,000 people using Arcade. And the resulting values I can map to colors that are then applied to my features. We'll show you more examples of this later, but that is fundamentally how visual variables work. Visual variables also allow you to do some pretty cool visualization techniques like scaling your symbols, your symbol sizes by ViewScale. Not all sizes work for all scales. If you have a lot of points, such as in this world cities data set, and you zoom out and you give them large sizes, they're all going to overlap and they won't look good. When you zoom in, they will look good, but if they are smaller, then it'll be more difficult to see. And with that, let's go ahead and dive into some demos. All right, so for the first example, let's take a look at this data set of weather stations throughout the world that I just showed in the slide. At this scale, these dots look great. I'm just giving them a 3-pixel size, Dodger blue color with a thin white outline, all being set within a simple render instance. As you can see, it's just a few lines of code. I create my renderer there, then assign it to my layer. This works well at this scale, but as I zoom in to, say, the United Kingdom, these dots they kind of take on the appearance that they look a little smaller. They become less visible, and as I zoom in closer, they become even harder to see. You can kind of see them throughout here, but it's pretty easy to not pick up on them as you pan around. Well, let's zoom back out to this scale, and I'm going to click this button to enable auto size by scale. What this does is I'm generating a size visual variable that I'm going to apply to the layer or to the renderer. And that is taking on an arcade expression, which all it is $view.scale. And that's what it's going to return as the view scale. And then it's going to map particular view scale values to symbol sizes. So as I zoom in, the symbols should grow larger. And as I zoom out, they'll grow smaller. So at this scale, the symbol size is 2.9 pixels. But notice that value as I zoom in. You can see these dots are getting larger. What's interesting about this is this growth and size is almost imperceptible to your eye. And that's good. It's natural that you view it that way. But as you can see, as I zoom in, they progressively get to a size of 7.5, which is exactly what I want at this scale. They're very visible to see. I don't have to wonder where my data is. Okay, if I switch over to my code, all that I have to do to get that size variable is to call a function that is called, it's a create render function, but it's part of a suite of modules that we call smartmapping render creators. So if I just want to see the location, I can call this location render creator function, give it my layer and view, that's a common parameter for all of these functions, and then I can indicate if I want my size to be optimized by scale. And if I indicate true, so that's indicated if I click that button, then I can get a response back and it will apply that layer, that renderer back to my layer. Well, let's say that I want to add a little more to this application. I want to view not just the location of these weather stations, but I want to color them based on the temperature measured at each station. I can do that using a color visual variable. So I've got my same setup here for the default color being Dodger blue, but I want to override that Dodger blue color with the temperature value. So I'm going to create a color variable, specify the temp field, then I'm going to set up a series of stops for various temperatures that might be meaningful to me. So if it's over 80 degrees, I'll make it red. If it's below 20, we'll make it blue. And then we'll interpolate using a diverging scheme such as that. And then I'm going to take that exact same size variable that I was showing before to make sure that those dots look good across all scales. Now let's take a look at the app. So here's what I see. I can see a lot of cold temperatures in the United States, in the Midwest particularly, but in the Southwest and Southeast, things are pretty warm. And then in the Southern Hemisphere where it's summertime, you can see warm temperatures there. And again, note that as I zoom in, that size variable kicks in, and and they will scale properly. Now I can even take this visualization a step further and add some more understanding by adding more visual variables. Let's say I wanted to show the wind speed and direction. Well, since the circle primitive doesn't work for me here, I can actually provide it an SVG path to create an arrow symbol. And that's what I'm doing right here. And on top of that, I'm going to add a rotation variable, and this will be mapped to the wind direction field. So based on the geographic direction of the wind, that's how the arrow symbol will be rotated in the map. I'm also going to add a size variable where for the wind speed. So slower wind speeds will get smaller, and larger wind speeds will get a larger icon. And there's my same color variable. So let's switch back to the app, and this is what I see. I see high winds in California and in the south here. Also, I see high winds pretty much everywhere, but you can see the variation as you zoom in. And then you get that color as well as the direction of the wind in each of these arrows. So pretty cool that you can do all of this with a single renderer. Okay, here's another data set I want to explore. In the United States, we recently had a presidential election in November of 2020. And because every election cycle, we see a ton of maps come out showing how people voted and where they voted. And I wanted to show the results of this presidential election on a county level in the context of some historical elections. So I put together this data set, this county-wide data set, which contains columns for the total number of votes for Democrats, Republicans, and other candidates from the 2000 election all the way to our 2020 presidential election. And so I wanted to use this to create a bunch of maps and explore this data. So let's take a look at this data in an app. Okay, so here I'm loading the data as a portal item, and I am setting a simple renderer on my layer. And I just want to see if the counties come in. So I'm going to give this a simple fill symbol, and I'm going to color the outline with this gray color. And this is what it looks like. So we have our counties, nothing special, nothing too interesting to look at here. So let's explore this data. I noticed that as I viewed this data earlier, that the number of votes for the president that went to other candidates other than the Republican or Democrat was abnormally high in 2016. So I wanted to explore that some more. So I added this size variable where I'm going to change the size of my marker. And that reminds me, I got to set this marker symbol here, and I'm going to say this is a circle, or I could even say like diamond. Okay, and I got a color here. The outline color, we'll make it, let's make it white. And then, okay, so I've got icons, and I want to change the size of the icon based on this votes for other. If it's 100 votes or less, it'll be 4 pixels. 100,000 votes or more, I'll give it a 40 pixel size, and everything else in between interpolates. So let's go back to that app, and let's give it a refresh and see if we see something interesting. Okay, we see this I guess the thing that jumps out to me is that Salt Lake City, so that Salt Lake County and Utah County are large. They're in fact larger than Seattle and San Francisco, which is interesting. But I basically just see a map of population trends. Other than what that jumped out to me there in Salt Lake, I don't really see any real useful information. It doesn't matter what variable in this data set I map, I will see the exact same patterns. The sizes may be different, but if it's Republican votes, I'll still see Los Angeles jump out. If it's Democratic votes, I will as well. So let's use the percentages of the votes to see if we can see something interesting. And as you note from this data set, I don't have a column that represents percentage of the vote. So I need to use Arcade to help me out here. So if I go back to my app, I'm going to switch over to this one here. So I have the same layer and a simple renderer, but instead of using a size variable this time, oh, note that it's a simple fill symbol, not a marker symbol, but instead of using a size variable, this time around I'm going to set a color variable to change the fill of my color. And rather than show, since I don't have the field I need, I will set a value expression on this layer. So this is where I define my arcade. So I'm gonna reference the votes for Republican, Democrat, and other for 2016, and I'm gonna sum them together. And I'm gonna assign it this name all. And that's what I'm gonna operate under the assumption that that is the total vote count. So I'm gonna normalize the other votes by all, multiply by 100, and then I'll map certain percentages to different colors. So these colors I get here, um, are up here. It's a sequential purple ramp. You may wonder where did I get those colors or how did I determine that? That actually came from a guide page in our documentation. So if I go to the documentation here and expand data visualization, there's this Esri color ramps page. And I use this all the time. I highly encourage you to check it out. You can search by types of colors or types of ramps, sequential ramps. So I want a purple sequential ramp, and let's say I want 6 colors, and then I search there, and I'll get 14 ramps that are assigned this purple category. And if I find one that I like, I can just copy the hex values there, or I can get RGBA values. Very useful page. I highly encourage you to check it out. So that's where I got the colors in this ramp here. So if I move over to my app, and then I refresh, this is what it looks like. I see Utah and Eastern Idaho immediately jump out, but I see a lot of midtones of purple, and I don't really see a whole lot there. I did note the national average as one of these midtones, but I can't easily tell what that is or where they voted above or below that average using this continuous color ramp. So I'm going to actually use a diverging ramp, or as in the documentation, we call it an above and below ramp. And this is my favorite color ramp that we provide. I've been using this a lot lately because I just really like how these colors play together. So this middle color will be the national average, brown will be below average, and green above average. So if I save that, refresh, now, okay, now all my data came in, and now I see that, again, Utah and Eastern Idaho jump out as heavily favoring third parties. So I can see that in some cases the third party votes not only outvoted Democrats, but they doubled or tripled that vote count. But not only that, but I can also see areas in the Deep South that voted heavily in favor of a single party instead of a third party candidate. So um, it's a fascinating map, and I think it shows the power of using diverging color ramps. Okay, now I'm going to take a look at the most recent election, and I'm going to look at the votes for Republican, Democrat, and other candidates in 2020, and I want to now map the winner. And again, I don't have a column in my data set that describes who the winner of each county was, but I could use Arcade to my advantage here. And so I've created my array that represents all votes, but now I'm going to use a helpful function in Arcade called decode. And what this function does is it takes a value, and then it matches it with another value. So what I want to do is I want to pick out the max value, in other words, the winner, and I want to match it to a string that describes the party that that was, because I don't have that attribute here anywhere. I just have a reference to the field name. So I'll take the winner and match it with, if the Republican count matches, then I'm going to return the string Republican. If Democrat matches, Democrat, other, and so on. And so this is, I should say, a unique value renderer, so it's not a simple render anymore. So now this renderer expects that I provide some unique value infos. These are objects that will match expected values with symbols. So I have a value for Republican, Democrat, and other that could possibly be returned from this expression. And I'm going to add labels for them that represent the candidates that will be used in the legend. And then I'm going to use a symbol or assign each a symbol that represents the winner. So if Trump won a county, I'm going to fill that polygon with a red symbol, and blue for Biden, red for other. This creates symbol method. All that's doing is it is a function that I wrote that just returns a fill symbol. So let's look at the app, and this is what I get. Now, this describes pretty accurately who won each county. The problem too is that the area does not represent what the population is. That's why you see so much red in here and not as much blue, because the blue counties actually represent highly populous areas, but they do not, the area of the county doesn't indicate that as much as the red does. So we'll need to do something else to transform this data. So in this case, I am going to add some visual variables. Let's go ahead and add an opacity variable. What I want to do here is I don't want to know just who won, but I want to know who won by a lot. So who won with the greatest share of the vote. And the way I'm going to do that is I'm going to get the total number of votes in addition to these variables I've already declared. And then I'm going to get the winner. And I just want to do a simple percentage. If you won with 85% of the vote, I'm going to make that county fully opaque. If the candidate won with only 40% of the votes, I'm going to say, well, they just barely eked out a victory, so I'm going to make it very transparent. And if I refresh, this is what I get. Pretty interesting map. You can see the areas that were very strongly towards the Republicans, as well as some areas on the coasts that were strongly supported Democratic candidates. But again, it still doesn't solve that issue that that Jeremy described before. We need to kind of reduce or remove the area out of the equation. And the way we can do that is with marker symbols. So instead of using a fill symbol, I'll just say simple marker, and then I'll place that here. And well, let's just refresh and see what we get. And now I get something like this. Doesn't really show me a whole lot. So let's say size is, I don't know, 5. And there, now we get something that kind of area is removed, but the red dots in the Midwest are still dominant. And we know that Biden won a lot more votes in the popular count, so we should be seeing a lot more blue here. So we need to use size to our advantage. So I'm going to add a size variable now, and this is what will happen. So let me enable that. So instead of showing the total number of votes for the size, I'm going to do something a little different. I want to show the gap or the margin of victory. And the way I'm going to do that is I'm going to do a reverse sort on that array of all of these values. So rather than, so what this reverse sort does is it essentially does a descending sort on these values. So the first value will always be the winner. And so what I'm going to do is I'm going to take the winner, and from that I will subtract the second place number of votes, and that is what I'll call the margin of victory. And I'll map a max size and a min size to data values of 100 or 500,000. So by the larger margin, the victory will show who won by how much in a certain county. So I will go back to my app, refresh, and I get a map that looks like this. Now this more accurately describes what happened in the election. I see these very populous counties immediately jump out. as large margins of victory for Biden in this election. But I also see some interesting variation in Texas, in Alabama, Georgia, and Tennessee here that show large, pretty strong margins of victory for Trump as well in those counties, and Florida as well, of course. Um, and this map is interesting because I can see areas where Biden underperformed, perhaps. So if I zoom into Miami-Dade County, you can see that this circle is pretty small. There's a high number of voters, but Biden basically eked out a victory, as evidenced by the transparent fill and also the small size in the margin. And because this area looks interesting to me, I'm going to zoom into it. But notice that as I zoom in, I'm now seeing that scale problem that I struggled with that weather data. And so I can actually use size variables to scale, to change the size by scale. So instead of setting a static sizes, I can set size info objects to my max size and my min size. And just they look exactly the same as the scale variables as I showed before, but this time I'm assigning it to the max size. So as I zoom in, that max size will get larger. And as I zoom in, the min size will also get larger to something more visible. So I will refresh one more time, and I see the same view as I saw before. But now as I zoom in, notice that these dots are a lot more visible to me. I can now clearly see who won in these smaller counties, whereas that was not visible to me before. As I zoom out, they shrink. So you can do a whole lot using arcade and visual variables in your maps. Now, I wanted to do something a little more to explore this data. So something popular that you see every election is showing how the vote shifted in each area. And so I could use arcade to indicate shift as well. So what I'm doing is I am getting the share of votes for Democrat in 2016 and 2020, Republicans and the other candidates, and I'm going to just take a raw difference between those two years. And then I will use the same exact decode method to get the predominant change. So which of the parties had the strongest positive shift? This is basically what's happening here. And it's the same setup as before in the unique value render. For my label, I'm not going to put candidates because the candidates change between elections, so I'll just indicate the party. And for size, I'll use the exact same expression up to the final return line. I don't want to, the size, I want to use the actual value of the change for the winner. So that's what I'm going to do here. Then I set up my size variable with these numbers. So if there was very little shift, it'll be given a small size. And if there was a shift in 30 percentage points or more, it'll be given the max size. And so I will move over to this app, and this is what I see. So it's pretty interesting. Now I see Utah and Eastern Idaho, those counties that voted for third-party candidates in 2016 are now shifting very much towards the Republican candidate. Rio Grande Valley, a heavy shift that way. And I also note that Miami-Dade County had a strong shift toward Trump in 2020. That's why that result for Biden was so weak there. So it's a pretty fascinating map to look at and explore. I created this version of it, which uses a sim symbol rather than a marker symbol. So this is that multi-layer scalable symbol that I described in the slides before. So I have a right arrow indicating a rightward shift and a left blue arrow indicating a leftward shift in votes. And if it's a third-party shift, then I give it a yellow arrow that points up. And so this is, I think, a nicer view of it. You see some styles of maps like this in the news. So now I can see where the strong rightward shift was, whereas in most areas of the country, there was still a leftward shift in 2020. And because I have so many columns in my data set and I have Arcade at my disposal, I added a slider that allows me to shift between the years and see how voting in each election shifted for each election. So you can create some pretty cool immersive apps using arcade, sim symbols, and visual variables, all these topics that I just discussed. This app I describe in a lot more detail in our arcade session, so I encourage you to go check out that session if you're interested in apps that show how to generate arcade expressions for data exploration. Okay, now I'm going to show you a visualization style called dot density. Dot density is a style that allows you to randomly render dots representing a fixed value within a polygon's boundary. So it's basically a quick and dirty way of visualizing something like population density. In this map here, one dot equals 400 people. So each dot you see there is a representation of 400 people, and it's randomly placed within each polygon. So now you can see how densely compact certain areas are or not, as you see in some of these rural areas. As you zoom in, you can see that the density visualization gets harder and harder to see if you maintain that fixed count. So in our render, we give you some pretty cool goodies that I'll dive into right now. One is the ability to change the dot value by scale, and another is that you can not only map just one dot representing one variable, but you could do dot colors representing other variables. So let's take a look at what that would look like. Now I have created a dot density render in my app for that layer of population, and note that I've set a dot value of 400, and I can indicate in my legend what each dot represents. So I'm going to say one dot is 400 people, but if I had other data, I could say one dot is 400 cows or some other variable. The reference scale allows me to match a scale at which this dot value works. So after doing some basically quick and dirty trial and error, I've determined that this view scale works for this dot value. Now, as I zoom in and out, that dot value will scale properly according to that change in scale. I also have a blending option, which I'll show you in a second, but I can now break up that population into subcategories. Now, this is where you need to be a little careful. I can't just pick any variable here. I can't say, oh, I want to color it based off of people who make $200,000 a year or more, and then people who own cats, and then people who earned a high school degree. That type of visual doesn't work. You need to pick subcategories that belong to a larger order. So in this case, it's educational attainment. So I'm breaking it based on different attainment levels. So my data set tells me the number of people who didn't finish high school, those who went to some high school, those who finished their diploma, those who completed some college, those who completed a college degree of various levels. Okay, so now I will go back to this app and I will refresh it. And now I get a pretty cool view of Chicago in this case. I can now see not only population density, but I can see population density based off of attainment level. So up in Evanston, I can see a large number or a dense population of graduate degrees. Let me zoom out a little bit. Okay, so one dot is, let's go to 10 people. There we go. And then I see a bunch of bachelor's degrees. And then as I move in certain areas of Chicago, I could see areas where no high school was completed, those who completed high school but didn't move on. And then as I get out in these rural areas, it gets a little harder to see some of the patterns. I can still pick out some patterns that are predominant, but it gets a little more difficult. I posted this out on Twitter a week ago or so, and someone called me out on this and said that it was hard to read, and they're right. I want to acknowledge that. That's because this visual it walks this fine line of having too many colors, and I'll describe why. This person said that the red, the purple, and the pink all kind of fight with each other. It's hard to pick out the differences between those two. Like they're not really sure if there's any areas in this map that show a predominant of attainment of some high school, because pink is hard to pick out between all of these colors. So that's where this API, the JavaScript API, really shines, is you can, with great flexibility, aggregate some of these categories with Arcade and the dot density renderer. So this is what that looks like. Rather than specify a field value like I did with bachelor's and graduate degree, I wanted to retain those categories. I can now say I want a value expression, and I want to combine those who completed some high school with those who didn't complete any high school, and assign those to a no high school diploma category. And then those who did finish high school but didn't complete any college degrees, but I'm also going to lump associate's degrees in here. I'm just going to say they attained a high school diploma. And that breaks it down into 4 categories with very different colors, and that will make this map so much easier to read. And this is what I get. I get a much easier map that shows graduate degrees, kind of this uh, combined or like area where there's a lot of graduate degrees and a lot of bachelor's degrees, and then a bunch of areas where there's a high school diploma and areas where there are not people who completed high school. You may note more than just 4 colors here. That's because I've opted to blend my dots. That's if I set that value to true, that's my visualization. But if I choose to not blend the dots, I'll get something like this. So it may show patterns that are easier to see. It just depends on what you need. I think that the blend dots is nice because in Lincoln Park, these areas, it allows you to see that it's not as predominantly bachelor's degree as you might otherwise think. You see a large mixture of attainment levels. Now, as I stated before, if you're really if you really are interested in the predominant level attained, dot density may not be the best style for you, because if you look in the rural areas, I cannot easily tell at all what the predominant type is. So that's where the predominance render really helps. If I switch over to this visualization, I can now either fill the polygon with a solid color, indicating the predominant winner or category, or I can use graduated symbols such as this to show the total using size and the predominant category using color. So these areas that were more difficult to see with dot density are now readily visible. And that is this predominance render. I could configure all with Arcade, as I've showed you in those expressions before, using decode, or I could use this helpful smart mapping function. So smart mapping is composed of a bunch of functions called create renderer or create continuous renderer, and you just have to give it a few variables. In this case, I'm just giving it the fields that I want to consider. So whichever of these fields is predominant, it will shade it based off of a predefined color scheme. In this case, I gave it a color scheme that matched the density renderer, so I could compare them. But then you have a bunch of other options to scale it by size or to sort it in a particular way that are very helpful. And all of these creator functions are found in these smart mapping folders in the API. So I encourage you to check out the API reference. If you search smart mapping, you'll see all kinds of options available to you. And finally, I want to show you the relationship renderer. In traditional cartography, this is called bivariate choropleth. It's this concept of taking 2 numeric fields and assigning them both sequential color ramps and then overlaying those color ramps to see if there's a potential relationship between the 2 variables. So if you look at this legend, I have this variable for household size, and it's given this blue ramp. So the larger the households, the deeper the blue that feature will have. Then I have a home value attribute, which is mapped along an orange ramp. So the larger the higher the home value, the more orange the feature will be. And those 2 are overlaid. So if a feature has a high or large households and expensive homes, then it will be given this brown color. And if the opposite is true for both, then it'll be given this tan color. So if I look at this map of Phoenix, I see some interesting spatial patterns. I see that South Phoenix and West Phoenix, you have large households, so a lot of people living under the same roof, but they live in less expensive homes. And you could translate that to smaller homes as well. Then you look at Scottsdale and you see that there are more expensive homes, but the households tend to be smaller, so maybe just 1 or 2 people. And then you see where those 2 converge on a positive end. So in Gilbert and in North Mesa, you know there are large households, but they also live in expensive homes. So larger households and probably larger homes as well. And then there are areas where there's smaller households and they live in cheaper housing. So if you look at Tempe area where the university is, then that makes sense. College students probably live in cheaper housing and they don't have as many people in their household. This you could also configure with a large arcade expression and a unique value renderer. But all that's required is calling into this relationship render creator from smartmapping. And it's pretty slick. All you have to do is give it the two fields you want, the number of classes. In this case, I want a 3x3 grid, and then it will give you back a render that you can then set back on your layer. So it's smart mapping makes your life a lot easier in a lot of these scenarios. And I also wanted to point out that this layer is taking advantage of layer blending. I'm setting a multiply blend mode so that I can get this hillshade layer to come through my polygons. And it gives it a really nice touch. Okay, hopefully those demos gave you a good sense of what visualization capabilities are available in the JS API. I wanted to cover a few things before wrapping up, and one of those things is smart mapping. I've already talked about this a couple of times, as they are a set of APIs or creator functions that allow you to easily create renders based on a particular field or expression for a given layer. Smart mapping was really designed to help you understand your data better. It's not everyone is a cartographer, and even those who have studied cartography still struggle with it at times. They struggle to know which colors work best together. They struggle to know which color scheme works best against a particular base map, or how to assign colors to breakpoints or stops within your data set. Smart mapping is a set of APIs that helps answer all of those questions for a given data variable or data set. It's not something to use in an everyday app because you want to be very intentional about the visualizations that you create. You don't want to just have the API decide it for you. You need to use this kind of as a starting point, and then you make very specific decisions about your visualization after that. And there's a number of guides and blogs I've written about this topic that I encourage you to check out. You can see that these APIs are pretty simple. Just give it a layer and a view, a field, and in some cases a theme. And all you have to do is set that render back on your layer. Again, not something you do in an everyday app, but something you can use certainly in data exploration applications. There's also point clustering. We have a demo theater that in which we describe clustering in more detail. It's a method of aggregating your point data into meaningful clusters that allow you to declutter the view, so to speak. So I encourage you to check out that session if you're interested specifically in clustering. Also, there's a concept called multidimensional data exploration. This is really all about animating your data. And I showed a little bit of this with that election data set, but we also have other apps such as this ocean application, which allows you to explore various variables at different depth levels and animate temperature, salinity, current direction with a slider. So this is great for exploring different dimensions of your data. It could be time windows, or it could be depth values, Z values, or it could be a cohort such as age or income. So there is a session on data-driven animations in which we dive into some of these examples in depth. I encourage you to check that out. And finally, there's layer blending. I showed you this example for the relationship renderer, but basically what's happening is that I'm able to take a hillshade layer, as you can see in these areas of the map here, and blend it with that relationship layer, or that layer that has the relationship render. That allows me to see those geographic details that indicate why those census areas are so large. They're not inhabited as densely as, say, the Phoenix metro area, and that's because of the terrain. And so it gives you additional context. You also see the labels come through that layer quite nicely. We also have another session that talks about layer blending that I encourage you to check out. These are some links to resources that you can click on as you get access to this slide deck, but I also wanted to point you to my GitHub repo. If you go to Ekenes, that's Ekenes, on GitHub, and then to this repo, it's Conferences DS 2021 2D Viz. All the demos I demoed here are available in this repo, as well as the slide deck and any other information like links to blogs that may be of use to you. And I encourage you to please provide your feedback for this session by clicking that session survey link directly below this video. Let me know if this content was relevant to you, if there's any content that you wished you had heard that you would like me to cover next year. Please provide that feedback and so we can know how to meet your needs. And On behalf of Jeremy and myself and others on the JavaScript API team, I'd like to thank you for watching this session.
All right, thanks. That was great, Christian. Just audience, a little behind the scenes. Christian, I tried to record that session together, socially distanced, but it came out, the quality was so bad that he had to go back and record it by himself. So meant to be there with him, but you know, we'll be glad to get back to doing these things live. Great session, Christian. You want to take a few questions?
Yeah, let's go ahead and get going on those.
Okay, I'll start with an easy one. What functionality sets the JavaScript API apart from just doing all the styling from ArcGIS Pro, publishing as services, and making a web map?
Yeah, so there's kind of a lot in there. First off, I mean, that's a totally valid workflow, using ArcGIS Pro and saving it as a service, and that's and loading in the web map. That's a workflow that we obviously promote. There's a lot of functionality actually that the JavaScript API has that ArcGIS Pro doesn't, and one of those is interactivity, being able to dynamically update these renders, as you saw with like the OneOcean app, and with very fast performance. Yeah.
Or Anne's app from the Dev Summit plenary that looked at the age population by year.
Yeah, exactly. And kind of being able to pull together a lot of widgets and statistical queries, charts, kind of all into one immersive experience. Of course, Pro has, they have charts. I don't mean to say that they don't, and that they don't have interactive components, but there's a lot of performance benefits to using it in the JavaScript API, and layer effects as well, feature effects, I should say, where you can emphasize, desaturate, do all sorts of visualization effects within your app. I didn't necessarily highlight those because we do have a separate session that it's dedicated solely to visualization effects that you can check out.
Where Pro and the JavaScript API are similar would be in things that are in the web map. Those are things we work together with the Pro team on. So yeah, smart mapping is something that's built for the web. That's what the map viewer is built on. And that's completely built on top of the JavaScript API. Christian, why don't we take, let's see here. That's a good question. I'm new to using the JavaScript API and maps in general. We have a vector tile map service and it's working well. Is there a way to add feature layers to our vector tile service so that we can take advantage of renderers? Maybe I'll take a stab at that one.
Yeah.
So yeah, feature services are your friend, and the JavaScript API works the best with feature services. So publishing that data as a feature service and then consuming it through feature layers gives you the performance of vector tiles with the flexibility of not having to pre-cook or cache anything, and gives you that dynamic capability to change what you're visualizing without having to change the underlying tile set. This is definitely a place to go. Christian, is there one that you want to take next?
Yeah, let's just do this one on the top that got the most votes. I think we can address this really quick. How do you define that animated symbol like in the demo? I'm guessing this is the hurricane one that I showed early on. And our animated symbols available at version 4.18 of the API. That symbol is just an animated GIF, and I use the picture marker symbol. So that slide that showed the picture marker with just that slide shows the snippet for how you create that. And yeah, that's available in 4.18. There was a few releases, I don't know the exact version numbers, where we weren't supporting those in our 4X series of the API, and that's because we switched over to a WebGL rendering, and there were some kinks and things that we needed to work out before we could support that kind of thing. So yeah, we've supported it for a while, also in 3X. It's just that there was kind of this awkward time where we couldn't get the support all the way there. But yes, you can definitely do that now.
Cool. Well, the next one, how to cluster features from two separate layers together as if they were a single layer. That's really not possible. You would need to combine the data sets into the same layer to get that clustering capability that takes all of the features from each layer into account. Anything you want to add, Christian?
Yeah, like if they come from two different services and you absolutely can't combine them into like one service, you could, use techniques like querying the data and combining them in a client-side layer of some kind and take advantage of it that way. It just sort of kind of depends on the requirements that you have. And if you have additional questions about that, you can contact me in the Ask Our Experts section, and I'd be more than happy to walk through it with you one-on-one. Just reach out outside the session in that Ask Our Experts tab, and we can chat more about it.
Cool. Would the renderer and or sim symbol affect performance when layer display grows? Like if you had lots and lots of symbols. While they are more complex, they end up getting staged and set up in such a way that we're not repeating it every time. So unlikely you're going to notice any performance difference, even if you had a lot of complex sim symbols. Now sim symbols can get very complex with visual overrides and geometric effects, and in that case you may start to see some performance. If you had 100,000 of them, that would probably be a lot. But in general, you're probably not going to notice. Let's see here. And then similar question, any performance issues if line styles to be displayed are too complex and contain many components or vertices? That's another benefit of the feature layer working with a feature service, is that it's going to ask for the data to be generalized and quantized such that you only get one vertex per pixel. And then when you zoom in, it'll get the next level of detail. So in general, you shouldn't really see too many issues if you have a lot of vertices. Now, where it can get complicated is if you've got the whole world as one feature and representing the coastline. Then you may start to see some performance degradation in that case, but in general, it should be okay. Christian, you want to take the next one?
Yeah, I'll bump this one up first because I think it might have been from the same person that came kind of right after the other. Can we make a custom line symbol style for a line feature that it needs a line to indicate the alignment and text along that alignment? So and they have like a pattern with text and dashes. My answer is I'm not sure. In our sim specification, yes, you can do that with a sim line symbol. That is something that we added support for this year. You'd need to use text as part of the geometric effect. That's a pattern we call geometric effect in the sim specification. But I am not totally sure if we support the text in there. So again, reach out to me or someone else in the Ask Our Experts web development section, and we can give you a definite answer as to whether that's supported.
Believe it is, yeah.
Yeah, I think it is.
Next question, does the 4x API render vector graphics faster than 3x? And the answer is yes. Although we have in the past changed the rendering engine in the 3x API to include the WebGL runtime that we're using in 4x. So you do get fairly good performance in 3x because it will use WebGL if possible. But the way 3x API uses WebGL is not the most efficient way. It essentially creates a WebGL context for every layer, and there's only so many of those that the browser lets you start up. So you can start to run into challenges if you have lots of layers. And then in general, the performance improvements that we put into the 4x API over the last year and a half haven't gone into 3x. So you're going to see substantial performance improvements over the 3x API in terms of feature layers. Probably got time for one more, Christian.
Yeah. Some questions were related to, sharing of code and demos. I posted that as an announcement, so hopefully you get a link to that repo. It may not be totally up to date, but I will get those demos in there in the coming days. One last question. Let's see here. There's so many to comb through here. I guess this one was voted up a lot. Sorry, where did that go? Oh, I have a lot of data, but I don't have lat longs. I have the addresses. What's the best way to display all my data on a map correctly?
Basically, you need to geocode those.
You need to geocode it, yeah.
Get them with actual XY coordinates and then draw them. And you can do that, separately. But that's going to give you the best performance, and it'll also be cost effective because you're only geocoding once and not every time you view it. All right, I think we're at time. Thanks everyone, and looking forward to seeing you in person next year at the Dev Summit.
Absolutely, and be sure to stop by Ask Our Experts if your question wasn't asked or answered.
All right.